Welcome to another coding tutorial, and in today's video I'm going to show you how to create this text distortion effect. First, we're going to draw a ring of circles, so we're going to start by creating a variable. Let's call it, how about points per ring, and we're going to start by setting it at 10. And then inside draw, I'm going to use a for loop to go through I equals 0 to I less than the number of points per ring. And then we're going to draw out a set of ellipses or circles around this ring. And I want the circles to be placed evenly between each other. So first, we're going to use the equation x equals to r times cosine of angle and y equals to r times sine of angle. And this is basically going to allow us to convert from polar coordinates to Cartesian coordinates by providing radius and angle of where we want to place the circle. And now we need to also define what r is going to be. So how about we set it at 100, and then for angle. So I want the circles to be placed evenly between each other. So we need to divide 2 pi, which is 1 revolution of a circle, by the number of points per ring. This is giving us the angle between each of the circle, and then we're just going to multiply it by I to get the exact position of each of the circle. Now we're going to use the function ellipse to draw out each of these circles, so x and y, and then how about we do a size of, let's do 10. Actually, I'm going to call it shape size, and we're gonna set it at 10. All right, so because it's a circle, we can just put in 1 dimension for both the width and the height. Let's click run. All right, and because the default origin point is at the top left corner here, and we want to draw this set of circles in the middle of the canvas, so what we're going to do is we're going to use the translate function to translate everything to the middle. So basically we're translating the origin. So width divided by 2 and height divided by 2. All right, and now you can change the number of rings, the number of points per ring. You can change the size of the radius, and you can change the shape size. Great. So I'm going to actually set radius at 100 for now, and let's do point per ring for 10 as well. Okay, let's do no stroke, and let's fill it with the color black. Change the size to 5. Great. So now what we want to do is that we actually want multiple rings. To actually get the text distortion effect, we need to be able to draw the text on top of a set of many rings, right? So I'm going to set another variable. Let's call it num rings for the number of rings. Basically, we're going to start small at 3, and I'm basically going to write another for loop to make this a nested for loop, and it is actually going to be the outer loop. So let's I equals to 0, I less than num rings, I plus plus, and then we're going to put this for loop inside, and make sure that you change this to j. All right, and if I click run now, you only see one set of ring. Why is that? It is because basically the radius is the same, right? So we need to change the radius size based on which ring it is. So what we're going to do is inside this outer loop, we're going to set r to be equals to, how about we also set the minimum radius and the maximum radius. Actually, let's start simple. So we're going to do I times like an increment of some sort. So let's do, how about increment is 100. So we're going to have a radius of 0, 100, and 200, right? So what we want is we want to set a minimum radius. And actually, instead of doing a fixed increment like this, what I'm going to do is that I'm going to set a minimum radius and a maximum radius. And then we're going to calculate this increment based on the distance between these two radii and the number of rings. So let min radius equals to how about 50, max radius to be 150. And then we don't need this increment anymore. And we have this number of ring, right? So basically, because we have 3 rings and the difference between these two radii is 100, so it's going to be an increment of around 33, right? And the calculation is max r minus min r divided by number of rings times I. Okay, run. Ta-da! And now you can change this to have a higher number of rings, or you can change the min and the max. Then you can kind of play around with this more. And you can change the points per ring too. Great. So now we have just this really straight line of circles, right? Because the angle is spaced evenly, right? Based on the number of rings. What if we want to create some kind of distortion, which is exactly the effect that we want to do? So what we're going to do is we're going to set a new variable. Let's call it distorted angle. I'm going to set it equals to angle right now, and then I'm going to replace it inside here. And now it's still the same. But what if we add it by a certain number? Let's do 100. You did see a change, right? Basically, the starting angle, if I zoom in, you can see that it is shifted by that amount, by 100. But all of the rings are shifted by the same amount. So it's still giving you this straight line. So what we want to do is actually set this to be different based on which radius it is. So how about so it is going to be r, right? So we do r instead of just a fixed number. Then now you get some kind of this, a little bit of a wavy line, right? So basically in each ring, we are shifting it by the amount of r. And you can play around with this. So what if I multiply it by a distortion factor? And what should this factor be? How about I do it by 2? Not bad. 10. Now it's almost as if it's only shifted by a little bit. What if we do it by 0.1? And you can play around because the different variables here will also dictate the shape. Now, kind of looks like a flower. If I do a higher number of rings, look at that. So play around with this. And this is the linear distortion. But what I actually want is not a linear distortion. I want an oscillated distortion. And what that means is instead of it shifted by a linear amount in each ring, I want it to shift back and forth. And I can do that using a sine function. What if we add it by sine of r? So sine of a number will spit out a result between -1 and 1, right? So right now we're basically adding -1 and 1 to the angle. So let's see what that looks like. You can see that it makes this a little bit of like a wavy line, but it's quite sharp, I guess, the effect. And we can play around with 2 other factors here. 1 is amplitude and 2 is frequency. So I want you to look at this graph quickly. So we're going to play around with frequency factor and amplitude factor. The blue line shows a normal sine function. If I or not to change anything here. So if amplitude is 1 and frequency is 1, you get the same image. So if we play around with the number inside here, if I increase it, what do you see? You can see that the frequency, or one shape, one full pi shape, is now has a smaller period, right? So between 0 and 2 pi, there are a higher number of these waves. So basically, if I set it at 2, there are a total of 2 waves between 0 and 2 pi. And if I do less than 0, then you can see that if I do 0.5, then you only get half of a sine wave between 0 and 2 pi. And so the period, so how long it takes for a sine wave to complete, will be longer. And in this case, it will be between 0 and 4 pi. And now, how about this amplitude here? So with the default value, right, of amplitude equals to 1, we get the range between -1 and 1. And as you imagine, if we increase this, basically the amplitude is higher. And if we decrease it, the amplitude is lower. And if we do it to a negative number, it basically just flip the sine wave. So let's play around with this in our equation. So how about I multiply, let's set this as a variable. Let's call it amplitude factor, and let's see what would this change. So let frequency factor be equals to 1 for now, and amplitude factor be equals to 1 as well. Still the same. We're going to change the frequency factor. Let's do it by 2. Interesting, right? What if we make it smaller than 1, which means that it takes longer for a sine wave to complete, which means the shift to the angle will be smaller. So let's do 0.1. Maybe we do, look at that. If we do like super small, it is a straight line, right? Because the shift to the angle is really tiny. Now, what if we increase the amplitude factor? Looks interesting. What if we do it to be less than 1? Okay, so play around with this, and I have played around with this myself already, and the number that I liked was 0.03 here and amplitude of 0.2. And I want to get a bigger radius. Let's do 300. So it's basically is off the sketch, and we're gonna do a lot more number of rings, and let's do 100 points per ring. Actually, let's just come back to 50. Right, so the middle is not too dark. Cool. Now that we have this set of rings, what we're going to do next is that we're going to write the text on top of it. And we're not actually using any text functions. The trick is we're actually going to be using an image, and we're going to get the pixel information or the color information from an image and then do something with it. First, how about we upload the image? So come to this arrow here, click the plus sign, and then click upload file. Then this is where you want to drag and drop your image file. Once the image is uploaded, we're going to first create a variable called img, and then we're going to preload the image onto the sketch. So function preload, and then we're going to set the variable image to another function called load image. And then inside here, we're going to put the name of the file. So in my case, it is flower.png. So flower.png, and make sure that you put it inside a quotation mark. All right, let's click run to make sure that it is running properly. Great. Now let me show you the picture of the image that we're going to use. So here's my image. It is an image of a text, right? Flower that has basically just two color, black and white. And what I'm going to do is that I'm going to basically mapping this image here that is in the Cartesian coordinates onto the sketch that we already have, which is in the polar coordinates. So what we're going to do is that we're going to get the values of the color information from x equal to 0 to x equals to the width of the image and map it to the coordinates of these circles that goes from 0 to 2 pi. And that is for the horizontal axis. And as for the vertical axis, we're going to map it between y equals to 0 to y equals to the height of the image. And on the polar coordinates here, it is going to be between the radius, the minimum radius to the maximum radius. But we're going to be doing some scaling and I'll show you how to do that. We're going to come down here and then below here, I'm going to create two variables. Let's call them ref x and ref y. And basically this is going to be the x and y coordinates that we're going to sample from the image that you just saw. So we're going to map the angle, right? The angle in this polar coordinates here between 0 and 2 pi to 0 to the image width. And then for y, we're going to map it between, so here, this is what I was talking about. So let me call it sample y. We're going to actually scale it down to be between 0 and 1. And we can do that by subtracting r, which is the radius that we want to sample, by min r divided by max r minus min r, right? This equation will return a value between 0 and 1. So we're going to do sample y between 0 and 1, and we're going to map it to 0 to image height. And now let me just print out ref x and ref y to show you. And I'm going to also call no loop so that it's only printing this out once. And you get the values of the pixel values, right, between 0 and the width of the image, and then 0 and the height of the image. And now that we get the pixel values, we actually want to convert it to integer. So let's put in int for these. Because the pixel values that you want to sample is actually an integer, so that's why you want to convert these to integers first. Now, what we're going to do is that we're going to create another variable. Let's call it c, and we're going to use a function called get. So img.get, and we're going to provide x and y coordinates. So ref x and ref y, and this line of code here basically is going to return the color information. So basically we have a value of R, G, B, and A for each of the pixel that we sample, right? Now we're going to use this information to basically change the size of the ellipse, and that is how we're basically mapping the text onto the sketch here. So let's do let shape size to be equals to, so we're going to map C, and actually we're only going to map the one of the values here. So let's do red of C between 0 and 255, and we're going to map it between the size of 0 and, how about, let's do 3. Let's do a bit smaller. You can kind of see the word flower. So I'm going to do two things. First, actually, I want it to be a rectangle. Why? Why not? And then I'm going to also set the rect mode to be center. so that the anchor point is at the center of the circle. And then it is off the screen, and that is because my max radius is off the screen. So let's set it back to 200. Okay, so now you get the word flower, but you can see that it is flipped, right? So what we want to do, there is a quick fix that we can do here. Instead of drawing it starting at this direction here, we want to draw it here. And all we need to do is just multiply this whole thing, x, by -1. And then now it is being drawn starting at angle of 180. Great. So what if we want to have multiple of these? As in, we want a repeat of the word flower. So let's try to play around. Right now, the sample y here is spitting out a value between 0 and 1, right? So let's say that we want it to spit out value between 0 and 2, right? Which is not exactly what we want to do, but if we do this and we click run, we get a smaller circle. And that is because the reference y value here is only sampling between 0 and 1. So to actually get multiple of these shapes, right, what we need to do is that if I print, let me print this to show you. So if I print ref y, no, I want to print out sample y. You can see that it is a value between 0 and almost 2, right? But what we want is that we want a value between 0 and 1. But we want it to be 0 and 1 2 times. So let me actually put this as repeat y equals to 2, right? So we can do it actually quite easily by just using an expression called modulo, which is this percentage sign here, and do it with 1.0. This expression here basically is going to return a value of these decimal points behind these floating numbers. So let's click run again. And then now you can see that the number goes between 0 to almost 1, and then goes back to 0 to almost 1. And if I run again, you can see that now we have a repeat image of flower, right? There are 2 flowers. So if I want to do 3, now you get 3. Let's try to do this for the horizontal repeat as well. So how about we do let repeat x to be equals to 2, and then we're going to do, how about sample x to be angle, right? Multiply by repeat x, and then this time around, what we want is we want to do a modulus expression, but we want to do it to 2 pi. So basically, this expression returns the remainder between the division of 2 numbers. So because by multiplying this angle with the repeat of 2 or 3 or 4 and so on, it basically just increases it by that amount, that multiplication, right? And by doing modulus of a certain amount, it will basically just loop it between this range, between 0 and 2 pi, same as this, right? But the reason we have to do 1.0 is because we wanted to get the remainder, we wanted to get the decimal point of that floating number. Now let's click run. Oh, and we want to put sample x in here. We can delete this. And now we have 2 horizontal repeat and then 3 vertical repeats. And we can put these as global variables here. And I just want 1 here and then 3 for the Y, and then I want this to be 300 again. Okay, all right. And now the image is static. So what if we want to make it dynamic? It is as easy as just changing or adding frame count to the distorted angle here. So let's do frame count. And also comment out no loop. It is just moving way too fast. So how about we just multiply this by a certain speed. So let's slow it down. And there you go. All right, so the last part that I want to do is that I want to add some colors onto this. And I want to do it with 2 colors. We're going to create 2 more variables. Let's call it start color and end color. And these 2 colors are going to be these, which are yellow and pink. And then here, what we're going to do is that we're going to color each of the squares based on where they are in the Cartesian coordinates. So I'm going to create another variable. Let's call it x Cartesian. And this is going to be the location of x, which is in the polar coordinates, right? And actually, I need to put this after these. And this x, because we did this translation here, right? Where now this point here, x is equals to negative width divided by 2, basically. We just want to also shift it back, and we're going to do it by just adding it by width divided by 2. And then I'm going to create another variable. Let's call it t, and we're going to map this value. We can change that name later. We're going to map it to, we're going to map this x Cartesian, right, between 0 and width to a value of 0 and 1. And the reason that I want to scale this to be between 0 and 1 is because we're going to use a function called lerp color, basically to find the value, the color values between the 2 colors that I have placed earlier. So start color and end color. So start color, I think, is a color of yellow, and then end color is this pink color. And this lerp color here is doing a linear interpolation, which basically find a point between 0 and 1, but in this case, find a color between the yellow color and the pink color. And we need to provide 3 arguments, which is the 2 colors, right? The minimum and the maximum, and the value of t, which ranges between 0 and 1. And then now we're going to fill the rectangles or the square with the color here. And I'm going to actually change this to shape color, and then t here, let's do AMT for amount. Okay, let's see. It's not a valid color.
A few moments later.
Oh, I think I named it incorrectly. Start color. Start color and end color. The mistake in copying and pasting. Okay, let's click run again. And there you go. Okay, I actually want the minimum radius to be 0 actually. Okay, and then let's change the color of the background to 100. Let's go a little bit darker. All right, so here is my take on doing some text distortion without actually using any text function. I think there's a lot that you can play around with this, right? The different variables that you see here, you can play around with all of these. You can change the image. It doesn't have to be a text. It can be anything that you want. You can change the number of repeats here to get a lot of the repeating patterns. And you don't even have to have it move. What if you just do a static image and then export it as a PNG or something, right? This is actually the way that I did the set of 3 posters based on taking color information from my favorite Thai dishes. So you can check that video out if you're interested. And I hope that you enjoy this one and give it a try.